Okay, so the reason electrochemistry comes after thermodynamics is because we can deal with delta G's. Okay, so here we have a reaction. We want to know, is the reaction spontaneous? And remember, spontaneous is going to be, is delta G negative? Or we can also say spontaneous E0 cell is positive. So you can remember that. So that helps. But this actually wants us to calculate and then answer the question. So let's determine what's happening. Looks like we're in basic conditions here. Okay, so sodium here. So we need to identify oxidation. We need to identify reduction. It helps here to list the electrons that are happening here. So sodium going from sodium to sodium +1. And reduction is going to be, do you see here, hydrogen is +1 going to 0. So the way you write that is going to be H plus going to H2. So we need, and there's 2 of these. So you say, wait, what? Remember, auto-ionization of water here. This may not happen very quickly, but it can happen. All right, this is actually a very, very explosive reaction. Sodium metal with water. Okay, so here we're going to have 2 moles of electrons. So that means we need to have 2 and 2 moles of electrons here. So that will help things out. Now these don't make any difference in calculating our cell potential. So let's do that next. Oxidation occurs at the anode, reduction occurs at the cathode. So remember this here, this is the She. So that's 0. That makes things easy. And sodium reduction negative 2.71. Negative 2.71 volts. So cathode, here I'm just going to put cathode, so that's going to be 0 minus anode, where sodium does not want to take electrons, it wants to give them up. Oh, is that the She, or do I need to put this with water? Hold on. Oh, here we go. That's right. This is not the She, it's this one. Because we're breaking apart water. This is hydrochloric acid, this is water. Negative 0.83. Negative 0.83. That's okay, I can do that. 0.83. Again, see, I told you, matching things up is the tricky part. There's a crayon if you want some. Negative 0.83 plus 2.71. It's definitely going to be a positive cell potential, so that's good. Okay, so now remember, I'm going to give you this equation, but delta G equals negative NF E0. So yes, I'm calling it E0. Again, we're at standard conditions, so it's delta G there. Okay, N stands for moles of electrons. So we decided here we need 2 moles of electrons, so just put 2. Well, here, let's put 2 moles of electrons. Now, again, a lot of times it's easier for me to kind of do it like this. You don't have to, you can just use parentheses. F is the Faraday constant, which I will give you, 96,485, and it's C for coulombs per mole of electrons. So see, there's the moles of electrons. Now, E cell, now we calculated this in volts. Now again, when you take physics, you will be very happy to learn that 1 volt is a joule per coulomb. So that's energy per charge. So we put joules over here, we put coulombs on the bottom. You do have to remember this, I'm not going to give it to you, or you can just remember to plug and chug. But the units will cancel out. Look here, negative sign. So delta G is going to be negative. We know it should be spontaneous because we have a positive cell potential, and the math works out like that. Let's make sure I still have Faraday's constant plugged in. I do. Great. Okay. So negative 2 F times 1.88. So that's a lot. I'm going to go ahead and convert to kilojoules and round. Negative 363 kilojoules. So that is delta G, and we can say, yes, it is spontaneous. There we go.